Okay guys, welcome back to another video. Today we will take a look at the new section 2.4, which is greatest common divisor. So we let a and b be two integers. And then if you have d divide a and b divide a, and d divide b. Okay. So if you let d to be an integer such that d divide a and d divide b, we could say that d is a common divisor of a and b. That's what we know. Okay? And we have some fact of common divisor. Take a look at these three facts. Number one, if we have a set of common divisor of a and b, this set will never be an empty set. So it cannot be an empty set. Why? Because because 1 and minus 1 divide everything. So because 1 divide a, 1 divide b, and minus 1 and minus minus 1 divide both a and b. Okay, so 1 and minus 1 must be contained in this set, the set of common divisors of integers a and b. The second one, so if we have set of common divisor of if you have the set of common divisors of a and b, this set is going to be finite if a is not 0 or b is not 0. Okay, and the last one, if we have the set of common divisor of a and b and it turns out to be infinite set, then that means that a equal b equal 0. Okay, that means that if you have a equal to 0 and b equal to 0, any integer divide 0. Okay, any integer divide 0 for all integer d. So when a and b are both 0, the set of common divisor of a and b is going to be infinite set. Now let's try to find common divisor of 50 and 60. So we might start with divisor of 50 and divisor of 76. So let's start with the set. So the set of all divisors of, we might start with 50. What is it? We might start with set A, which is the set of all divisors of 50. So we might start from 1, 2, 5, right? 25 and 50. And the negative numbers of these divisors. So we're going to have minus 1, minus 2, minus 5, minus 25, and minus 50. This is the set of all divisors of 50. Now let's find the set of all divisors of 76. So what is it? It is going to be a set B. I will call it a set B, and we start from 1, 2, okay, 1 and 2, and the next number is 4 because 76 is 4 times 19, so 4 is a divisor, and then 19. Next number is 19, and 2 times 39, 2 times 19, which is 38, and itself 76, and the negative numbers. So we're gonna have minus 1, minus 2, minus 4, minus 19, minus 38, and minus 76. This is the set of all divisors of 76. And then let's find the common divisors of 50 and 76. So we have to start with A intersect B. So what do we have in this set? So we're gonna have 1 and 1, right? So we have to find the common elements. So we have minus 1, minus 1, minus 2, minus 2, 1 and 2. That's all of them. So we're gonna have minus 2, minus 1, 1 and 2. So this is the set of what? Is the set of common divisors of 50 and 76. Okay, and then from this example, if you take a look at the set of common divisor of 50 and 76, the largest value is 2. Okay, the largest value is 2. I will call it max of A intersect B, which is 2. And this number 2 is called the greatest common divisor of 50 and 76. So in this section, we will focus on this number 2, or the greatest common divisor, which is defined in definition 2.4.1. Now let's take a look at the definition. So we have to start with any two integers a and b, such that a is not 0 or b is not 0. Okay, then d, which is a positive integer, is called greatest common divisor, and it have abbreviation GCD of AB. And the GCD of AB is denoted by AB like this. Okay, ordered pair AB like this. It look like ordered pair, but this is the greatest common divisor of A and B. And then D is the greatest common divisor of A and B. I may write AB like this, which is greatest common divisor equal to D if and only if D satisfy the following condition. The first one is D must divide A and D must divide B. That's number 1. Number 2, if you have other divisor of A and B, let's say C. If C divide A and C divide B, then C must be less than or equal to D. Okay, so if D satisfy this condition, D is the greatest common divisor of A and B. Okay, so from this definition, we're gonna have the following trivial fact. So if A and B are integers such that A and B are not 0, number 1, we can always find the greatest common divisor of A and B. Number 2, the greatest common divisor of A and B is unique. So there is only one common divisor for each of pair of A and B. Just only one. And the third one, if you can find the value of the greatest common divisor of A and B, you can also have the greatest common divisor of A minus B minus AB and minus A minus B and BA. Okay, these common divisor will be the same. And number 4, the greatest common divisor of A0 is absolute value of A when A is not 0. What happens if they are both 0? If they are both 0, there will be infinitely many common divisors. Okay. 5. If A divide B, then the greatest common divisor of A and B is absolute value of A. Okay, for example, if you have A divide 4, that means that the greatest common divisor of 2 and 4 is 2. If you have 3, which is which divide minus 3 divide 9, what do we have? We're gonna have minus 3, 9, and the greatest common divisor will be 3, which is absolute value of minus 3. Okay, these are the true fact of greatest common divisor. Okay, let's go to this example. Let's try to find the greatest common divisor of these pairs of numbers. So we start with this one, 24 and 84. As we can see, you can switch the order of the number. And then we have to find the greatest common divisor of 84 and 24. So if you cannot figure out, you might start with prime factorization, or you try to write this number as the product of prime. 24 is 4 times 6, which is 2 squared times 2 times 3, which is 2 to the 3 times 3. Okay. 84 is 4 times 21, which is 4 times 7 times 3, which is, okay, 4 is 2 squared, right? It's 2 squared times 3 times 7. Now, let me rewrite this one because we have 2 cubed. For 2 cubed, we try to write 2 times 2 to the 2 times 3. As we can see, what is the greatest common divisor of these numbers? The greatest common divisor is 2 squared times 3. Okay, that means that the greatest common divisor of 24 and 84 is 2 squared times 3, which is 12. Now let's go to the next one, this one right here. If you don't like the negative sign, you might try to write 6 and 15 like this. You don't like the negative sign. I think you can find it instantly, which is 3. Okay, it's just 3 because 6, what is 6? 6 is 2 times 3. 15 is 3 times 5, and the common divisor is 3, so the largest one must be 3. That means that the common divisor of minus 6 and minus 15 is just 3. The third one, or C, minus 17 and 229. Okay, this must be 17, right? Okay, this must be 17 because, okay, let's try to write. So you might write 17 and 289 in case if you don't like negative sign. And 29 actually is 17 square. Okay, let me try to multiply 17 square. So we're gonna have 170 plus 70 plus 49. So we're gonna have 982, which is 17 times 17. And minus 17 is minus 1 times 17. So the greatest common divisor is just 17. Okay. And the last one is 540 and 450. So try to find the greatest common divisor. You might start with factorization. So 540, it turns out to be 54. 54 times 10. 54 is 6 times 9 times 5 times 2. For 6, you're gonna have 2 times 3, okay, and 9 is 3 square plus 5 times 2. So we can have 2 squared plus 3 cubed times 5. And 450 is 9 times 50. And 9 is 3 square. 5 is 25 times 2, which is 2 times 3 square times 5 square. Then let's try to find the greatest common divisor. As you can see, we have this number 2. So this one I may have to write 2 times 2 and 3. For 3 cube, I will write 3 times 3 square times 5. And this number right here, I'm gonna write 2 times 3 square times 5 times 5. And then let's find the common divisor. Number 2, 3 square, and 5. Okay, so that means that the greatest common divisor of 540 and 450 is 2 times 3 square times 5, which is 90. Okay, it's 90. That's it. So that's it for this video. So in the next video, I'm gonna give you the theorem involving greatest common divisor. And that's it for today.